Well, welcome back tonight. Our topic you'll see is called absolute extrema. Now remember, extrema is just plural for maxes and min, and absolute means it is absolutely the highest or lowest point. Now to find an absolute extrema, we use what we call the closed interval test. So let's jot through some examples. So given this great graph of f of x, I do want to just clarify the difference between that absolute and relative extreme. Now, remember, we have to have a closed interval, and you can clearly see that we have a closed interval and that our function is continuous. There are no holes or vertical asymptotes. So at this point up here, this is a relative max, and again, I just want to justify why. It is higher than the 2 on the side of it. Okay, a relative has to be higher than the 2 to the left and the right. I would say down here, we have a relative min. Okay, it is lower than the left side and the right side. I would say up here, this is absolutely the highest the graph goes. I would classify that one as an absolute max. It is absolutely the highest point, and there can only be one absolute max. And then I would classify this point way down here as my absolute min. Notice I don't need anybody on the left or the right to be an absolute. It is just absolutely the lowest point on the graph. Okay, so remember, relative has to have someone to the left and the right, but absolute can be an endpoint. And I just want to make that clear. It can be an endpoint, whereas relative cannot. So the first thing I need you to do is copy this word for word in your notebook. And this is the definition of absolute min or max. Now, this is used quite a bit in the AP, and you've got to catch that word absolute. So this is what it says. If f is continuous, let's underline that. That is a key calculus term. If f is continuous on the closed interval, then f of x must have an absolute max and an absolute minimum value on that interval. Now, you might be thinking, well, that seems pretty obvious, and I can draw a quick example. Let's say this is a and b. So if a is continuous on the closed interval, so basically I have to get from point A to point B without picking up my pen, then I have to have an absolute maximum value and an absolute minimum value. I have to have both. So I think it's very obvious on this function. Would you say you definitely have an absolute maximum value there? I would say so. But the other thing you have to catch is that you also have to have an absolute min. Now, it's not going to look like a min all the time in that traditional sense that you see like a concave up parabola. This, in fact, is my lowest point, so this point here would be my absolute min. It is absolutely the lowest point. Okay, now people get fooled by this absolute min and max. Let me give you another example, one that fools people all the time. What if I draw a straight line? Okay, so this follows the rule. I am continuous on the closed interval A to B. Endpoints are closed. I don't pick up my pen. I have to have an absolute max and an absolute min on this interval. Okay? Now, again, it's not in the sense that you're going to have a parabola and it looks like a max or min every time. There is an absolute max, and I'm going to say, let's just pretend that's a height of 3. I'm going to say my absolute max, and this should be in your notebook, is 3, and my absolute min is 3. Okay, they just happen to be the same thing. The absolute min happens to be equal to the absolute max. Alright, so again, what this is saying is as long as your function is continuous and on a closed interval, you have to have both an absolute max and an absolute min. Alright, so let's say we've got this example, and it says find the absolute extrema, again that's plural for mins and maxes, on the closed interval. So this is how they're going to say absolute. They're going to give you a closed interval. So you use that closed interval test. Alright, so I've got to cut this graph off at -2 to 5. Remember, that's like my x1 and x2 values. Those are the domain. Those are x values. So at -2, I'm at 2. And at 5, it looks like I'm at, I think it hits right there at 4. Okay, so basically this piece of the graph means nothing, and this piece means nothing, because I am strictly looking at the domain -2 to 5 and the closed interval here. So now watch the two wordings, and again, these descriptions need to be in your notebook. I have an absolute minimum value of, well, I would say this is the lowest the graph goes, and it has a value of 4 at 3. Notice the word value is the actual height, and at is where it happens. I have a maximum value, so if I find my highest point, let's see, it looks like the values at the actual height is 4, and I would say that happens twice. It happens at x equals -4 and at x equals 5. So I still have one maximum value, but it's happening in two places. Let's try a similar one. Again, find the absolute extrema on the closed interval -5 to 5. So if I count out my -5, and again, that's domain. Okay, so this means nothing. And if I go to +5, I think it's all the way down here. Okay, so this little piece means nothing. What is the absolute minimum value? What is absolutely the lowest this is going to go? It looks like a -16. Now again, that happens at x equals 5. The absolute maximum value, I would say, is up here. The maximum value is 7, and it happens at x equals 2. Really watch the is versus the at. The is the value, the at is where it happens. Alright, so our first goal here is to find the absolute extrema of the function. Now notice extrema, meaning plural, we're going to find both the absolute max and min. So the first thing I do is get my critical point. So I'll set that derivative equal to 0. So 1/2 times 4 gets me 2x cubed minus 8x. Set that equal to 0. To get my critical points, I can factor out a 2x, and I'm left with x squared minus 4. And then, of course, tee it up. I get x equals 0. There's 1x there. Here there's an x squared, so I should get two answers. X equals plus and minus 2. Now, here's the difference between just finding a regular relative absolute max and min and finding an absolute. All right? So now we're going to apply the closed interval test. Okay, the closed interval test is just a tad different from the first derivative test. So again, I just want to make a note. The first thing we did is we got our critical points. Okay. The second thing we're going to do is make a closed interval test table. And again, labeling is important here. So here's what I do. I'm making a table, not a sign chart this time. And here's how it gets labeled every time. This is x. This is who you are trying to find. I'm trying to find the max of f of x. Okay, so that's who I'm trying to find. Now the next thing I put on there are my closed intervals. If you notice, the original function had a closed interval from -3 to 1. So I'm going to put -3 on one end, and then I'm going to put any critical points that fell within that closed interval. So if I look at my my critical points, I had 0, plus and minus 2. So -2 definitely falls in there, and 0 falls in there, but does 2 fall inside there? No. So I don't even have to waste my time with that point because it's not in my closed interval, okay, from -3 to 1. Now at this point it's very simple. I just have to evaluate each of those points in f of x. Notice I'm not using the derivative. I'm using the original f of x function. Oops, and I think it was, I better go back and check, 1/2 x to the 4th minus 4x squared. Okay, now I do need an actual value because I need to know who's the largest and who's the smallest. I'm going to start with 0. When I plug 0 in, 0 minus 0 is just 0. That one's pretty easy. I'm going to plug 1 in. 1 to the 4th is 1, so I've got 1/2 minus 4, which is really 8/2. So I get a -7/2. When I plug -2 in, let's see, -2 to the 4th is a positive 16 times 1/2 is 8. -2 squared is 4, so I get -16, so I get a -8. And then lastly, I need to plug in -3. And as I substitute that -3 in, -3 to the 4th is positive 81, so I get 81/2 minus 9 times 4 is 36, so 72/2, which gives me a total of 9/2. Okay, so now I have to answer the question, and watch how my wording goes. I would say I have an absolute, and this gets written out in your notebook, an absolute max of, who is the largest number, okay, of 9/2, and it happens at x equals -3. Okay, watch who the max is and where it happens at are two different questions. And then I would say I have an absolute min of -8, and again this gets written out, an absolute min of -8, and I would say this happens at x equals -2. Alright, so our absolute test, or our closed interval test, is just a tad different. We're not plugging them into the derivative whatsoever. So we'll run through a couple more examples, and it's basically the same idea. We're going to make our chart, watch the endpoints, and just carefully take your derivative. Alright, so let's dive into the next one. Again, we're going to find out absolute extrema, and notice they give you that closed interval for the closed interval test. So let's go ahead and get those critical points. I'm assuming you can do that pretty quick on your own. Why don't you pause it, see what you get for critical points. Okay, don't cheat yourself. Pause it, see what you get. Hopefully you can verify my work there. Took my derivative, factor out a 12x squared, I get 0 and 1. Now again, we're going to do that closed interval test because it says the word absolute. That's what's sticking out that's different. This is x, this is who you're finding the absolute of, which is f of x. My closed interval goes from -1 to 2. Now I just have to ask myself, does 0 fall within that interval? Sure it does, so it goes there. Does 1 fall within the interval? It does too, so it goes in there. Now I just have to slow down and evaluate those points in f of x. I'm going to start with 0, that's typically the easiest. 3 times 0 to the 4th minus 0, of course, is 0. I'm going to go with 1. I get 3 minus 4, which is -1. If I go with -1, I get 3 plus 4, which is 7. Hopefully you would agree with that. So again, that's 3. That's going to turn into a plus 4. And if I go with 2, let's see, I get 3 times 16 minus 4 times 2 cubed is 8. So that gets me 48 minus 32 for a total of 16. And now just make sure you answer your question. Hopefully that was pretty straightforward. I would say 16 is my largest value, so I have an absolute max of 16, and it happens at x equals 2. And I have an absolute min of, let's see, -1, and that happens at x equals 1. Now notice, I don't have to justify for the absolute. This table is your justification. Okay, now it doesn't work with relative. You had to have a sentence describing the relative, but for absolute, we're good with this table. Alright, so again, I know this is, I'm finding the absolute min or max, finding both, relative extrema, and I've got a nice closed interval. So you can set up your closed interval immediately. We know this is the function, and we are finding it of f of x. Notice my domain goes from 0 to pi, so I can't use anybody outside of it. So now let's go get our critical points. F prime of x is equal to, I get 1 minus 2 cos x. Set that equal to 0. So I get 1 equals 2 cos x. 1/2 equals cos x. Okay, now for those of you that are trig lovers, let's just kind of talk through this. Basically, what you're doing is you're asking yourself who is x, or you are taking the cosine inverse of both sides. Alright, so to undo a trig function, it's not like you can take its square root to undo something. That's if it's squared. You use inverses in trig. So the cos and cos inverse kill each other, and I get x. And I need to know who cos inverse is of 1/2. Or basically, who is the angle that gets me an answer of 1/2. Well, I would say the cosine of 60 is 1/2. Now we've got two small hiccups here. First of all, we don't talk in degrees in calculus. I guess we can speak in them, but we're going to have to convert them to radians. And we've got to watch our quadrants. So notice I had a positive 1/2. So I would say all students tip cows and slow down and tell myself I could be in the first quadrant or the second quadrant. So in the first quadrant, that is 60 degrees. And in the fourth quadrant, that would get me, what would that get me? 300 degrees. And now I just have to quickly turn them into radians. 60, of course, is pi over 3. Therefore, 30 is just going to be some number pi over 3. Well, 60 goes into 30 how many times? 5 pi over 3. Now ask yourself, are you going to use both of those? Remember, your domain is 0 to pi. So I know I can use the pi over 3, but I cannot use this value here. It falls outside the domain of this problem. Now again, all I have to do is evaluate each function, and who are you doing that in? We'll look at who is labeled there. It says f of x. So I get 0 minus 2 sine of 0, which is 0. And on this one, I'm going to do pi next. That's the nicer one. I get pi minus 2 sine of pi. Okay, picture your sine curve. The sine of pi is 0, so that's just pi. And then I get pi over 3 minus 2 sine of pi over 3. All right, well, the sine of pi over 3, the sine of 60, is radical 3 over 2, which tells me that this 2 times this 2 is going to cancel. So I get pi minus 3 minus radical 3. So lastly, I just need to identify who my max and min are. Now, perhaps this is kind of freaking you out and you're getting a little nervous. Well, think about this. Basically, and if you really get stuck, remember pi is 3.14. You're taking pi that you have, you're dividing it by 3. So first of all, are you bigger or smaller than this value? If you take this value and divide it by 3, you're already smaller than that one. And now you're subtracting a number from it. So I know that this number is definitely smaller than this number. So I would say my absolute max is pi, and it happens at pi. Okay. Now, I just have to know if this number is positive or negative. Well, remember, 3 is approximately 3.14, and if you divide that by 3, you get 1.14159, etc. And you're subtracting radical 3. And we already know radical 3 is bigger than 1. If you don't know that, think about, you know radical 1 and you know radical 4. So I know radical 3 has to fall between 1 and 2, and it's going to fall closer to the 2 end. So I'm going to say that this is a negative value. And I'm going to say that my absolute min is radical 3 minus 3, and it happens at pi over 3.
Our next example, we have y equals the absolute value of x minus 3 on the closed interval 0 to 5. Now, I can't stress enough, we said this the other night, all these absolute values you are not deriving. Okay, you are not taking the derivative of. All right, we want to make sure that we sketch this. So, all I have to say to myself is which way am I shifting minus 3? Hopefully we all recognize that's to the right 3, and we'll make a nice positive absolute value graph. All right, so now we get our table going, x, f of x. Okay, slap your endpoints on there. And remember, I'm looking for my critical point, and that's when my derivative equals 0 and when my derivative does not exist. Okay, does this ever have a slope of 0? No, but it certainly has a derivative that doesn't exist, and that's right at 3. And 3 does fall in my closed interval, so I'm going to stick that in there. Now, remember, I'm just plugging these back into f of x. So if I plug 0 back in, I get 3. If I plug 3 in, I get 0, and 5 in, I get 2. And then lastly, we'll just justify. The absolute max is 3, and it happens at x equals 0. The absolute min is 0, and it happens at x equals 3.
All right, we've got a real nice easy one here. Again, we're going to find all absolute extrema. All right, so let's get those critical points. I'm setting my derivative equal to 0. So I would say 2x equals 0 and x equals 0. So does that fall within my closed interval test? Remember, this is x, and my closed interval goes from negative 3 to 3. 0 does fall in there. And I'm labeling this f of x, of course. Now, all we're doing, again, is evaluating these functions in f of x. So off to the side, I'm evaluating f of negative 3, f of 0, and f of positive 3. Well, negative 3 squared is 9. 0 squared is 0. Positive 3 squared is 9. So I chose this one on purpose. I just want to practice writing it up again. I would say there is an absolute max at x equals positive and negative 3. I would say the absolute max is 9. And hopefully you agree with that. The maximum value is 9. It happens at x equals positive and negative 3. And then, of course, my absolute min is 0, and it happens at 0. Hopefully a pretty friendly one. Next example, f of x equals x over x minus 2 on the closed interval 3, 5. So let's quickly take our derivative and set it equal to 0. Now again, I can't make like a beaver and split because my one term is on the top, not the bottom. So I'm going to go a little quotient rule. Low, d high of course is 1, minus high, d low is 1, all over x minus 2 squared. And let's clean that puppy up before we set it equal to 0. I get x minus 2 minus x all over x minus 2 squared. X minus x is garbage, so I get negative 2 over x minus 2 squared. That's what I'm setting equal to 0. Now again, because it's a fraction, you have to set the top equal to 0. That's when the derivative equals 0. And you have to set the bottom equal to tell us when the function is undefined. So does 2 equal 0? Hopefully you're saying, heck no, that makes no sense. That's just garbage. And on this side, I'll square root both sides, and basically I get x equals 2. Alright, so now I go back and grab my endpoints. Notice my domain was from 3 to 5. Okay, my closed interval test goes from 3 to 5. Do I even have to test this point? Okay, and the answer is no, and don't waste your time doing it because that answer will be wrong. This does not fall within the domain 3 to 5. So I'm actually only testing the endpoints, which seems kind of odd. So I need to plug in, let's see, 3. So I'm going to get 3 over 3 minus 2 is 1. So I get a 3 there. And when I plug my 5 in, I get 5 over 5 minus 2. So that's 5 over 3. So hopefully you would agree you have an absolute max. Absolute max is 3 at 3. And the absolute min is 5/3 at x equals 5. Well, just a quick recap. If you want to find any relative extrema, all right, that's when you make your sign chart. And you always label f prime and f on top on the bottom. If you want to find absolute, we're going to do that closed interval test, and this time you're labeling it x and f of x. And hopefully that sums up the two things we've been talking about this week. Well, we look forward to seeing you tomorrow. Have a great night.